Well, welcome to another Lightblade Learning Lab. No, this is not going to be a maths lesson, although many of you guys will recognise this from your high school days. My plan is to do some graphics work on the little box that we manufactured last time in our cardboard engineering project. But I realised that the audience that I've got for these videos could range dramatically from school kids, maybe 12, 13 years old, up to very mature graphic artists. And on my other video series, and I regularly get asked questions like, I've imported a picture and I want to cut the outline, but I can't. Can you help? Well, I think that demonstrates a lack of understanding of graphics. I'm going to start off by tackling the very basic things about graphics. There are two types of graphics that we're dealing with. One of them is called vector graphics and the other one is pixels or bitmap graphics. Now, the reason I've brought poor old Pythagoras into it, despite the fact that he's been dead for 2,600 years, is that his work is still very relevant today in all the computer graphics programs that we use. Without boring you too much, I know that it was bashed into me, the square on the hypotenuse is equal to the sum of the square on the opposite two sides. So I still remember the mantra, even though I didn't actually grasp the concept at the time. I think it's fairly obvious the way that I've laid it out here. Look, this is a special set of golden numbers, but it works for any set of numbers, provided you've got a right angle in this corner here. And that is, if you draw a square on this side and a square on this side, which is the two shorter sides of the triangle, and add the areas together, the area that you finish up with is exactly the same area as the square that you get on the longest side. Don't forget Pythagoras. Now, as I said to you, there are two types of graphics. All graphics are based on mathematical equations. Now, we're not going to get into any maths, so don't get too concerned. But what I wanted to show you was that a circle is basically defined by its radius and the position that you put the circle on the page. So if we know where it's going to put the center of the circle and we know its radius, mathematically there is an equation which is, as you can see using this triangle here, based on Pythagoras, which allows us to construct a circle mathematically on the page. And there is a formula for a line, y equals mx plus c or y equals mx plus b, depending on which part of the world your maths teacher came from. Again, I'm not going to go into any details there other than to say that a circle and a line are the only two things that can occur in vector graphics. All other shapes that we see are combinations of these two mathematical equations. Now I can hear you say, why do I need to know all this? Well, let's quickly go to Microsoft Paint. If we go up here and we select the thinnest line possible, here we go, we'll choose a line. Now from this little graphic tablet at the top here, we've got all these shapes. You'll see that they're all combinations of straight lines or curves or bits of circles. So all of these shapes can be generated mathematically. And when you use this program, the first thing you do is you'll hold your mouse down and you draw a line. Now at the moment you can see, provided I don't let the mouse go, this line goes wherever I want it to go. But what's actually happening in the background there, we've got the first point that I put down as the center point or the fixed point, and then wherever I move my cursor, the computer is calculating where I want to finish up, and it then draws a straight line between where I started from and where I finished up. It's calculating that line, and the calculation bit is the vector graphics. Now when I let go like that, I've no longer got vector graphics, because this is a paint program which is basically a pixel based or a bitmap based program. At the moment that looks like a perfectly good straight line, but if we go up here to the magnifying glass and we start zooming in on this line, we're looking at pixels. We're not looking at a straight line. Okay, we're now in my CAD program and I'm going to try and illustrate to you in a little bit more detail exactly what's happening with that paint program. We draw a line and I'll draw a line exactly as it happened, and you can see I can move my line around here exactly as we did in the paint program. And now I will stop. In this particular program, as I zoom in, if we watch very carefully, you can see that the squares are getting bigger and bigger and bigger, but hey, the line that I'm zooming in on is still remaining absolutely a line. I can never get rid of the line, and that's because the line is redefined every time I move the resolution. The line is redrawn to suit the resolution of the screen. These squares in the background are basically pixels. So what we did in paint was basically draw a vector line which passed through all these pixels, which are these squares. And then what we had to do was follow a rule. And the rule was, if the line passed through a pixel, then colour it in. And so let's just have a look. You'll see we've coloured that one in because the line has passed through the pixel. Even this one here, look, the line has passed through a very small part of the pixel, but we've coloured it in. If the line covers a pixel in any way, shape or form, then make that pixel black. And so if we zoom out now, you can see that what we're actually doing is producing a fairly crude copy of that vector line. That's the difference between vector graphics and bitmap graphics. Bitmap graphics, once the vector has finished its work, it's frozen in time. It's like painting by numbers. Whereas here on a graphics program, every time I zoom in, the maths in the background is recalculating the line, and all I'm seeing is a line that is 1 pixel wide. Now this was originally 1 pixel wide, and so as I zoom in, I zoom into the pixels that I froze in time. Now the reason I'm explaining this is vector graphics you can cut. Pixel graphics you cannot cut. All you can do with pixel graphics is to engrave them or scan them in RDWorks. Now with vector graphics you have the option to both scan and cut, but with pixels you only have the option to scan. Now in my engineering world I only ever work in vector graphics with this CAD package. Well, I've just drawn a little pattern of hexagons there and now we'll just go about replicating that a few times. So now what we've got to do is to remove all the ones that we don't want. Okay, and now we'll go around and we'll trim everything that's outside the circle. What we'll do, we'll put an oval shape, and that's better. And we'll put that on the centre of that line as well. Okay, and now we can remove all the stuff inside there as well. Okay. So we delete all that, and then we'll trim everything else from the inside here as well. Okay, so now we've got a nice intricate pattern on the side of our box. We can put a name inside, and let's choose a font. There we go. Now what we're going to do is to copy all of that. Let's just take the center line off, as we don't need that anymore. And then we'll copy all of that. And I'm repeating that because I want to do that in 2 different ways within RDWorks. Now at the moment all of this is vector stuff. So if I save this as a DXF file, previously we were cutting this box from the inside and the other side was the hammer finish. If we want to do engraving and cutting, then we're going to have to do it all from the same side. And so consequently we're going to have to work from the good side. Okay, now at this point we've got to stop and think, because several issues arise from this design. The first issue is that if we look around here, we find that we are going to have a circle which goes right round the outside here, and a circle that goes right round the inside here. Now that means that when we do a cut, the middle is going to fall out and all this lot is going to fall out, and all we're going to be left with is a big hole here. So what we have to do, and it's very easy to do it in a CAD program, and it's certainly not easy, in fact I haven't found a way of doing it in RDWorks. So you've got to do all this preparation work before you go into RDWorks. In this CAD program it's very easy because I've got a trim command up there and I can just do this. Now it's not instant and it's not simple, but I can go round and I can trim. We need to make sure that these pieces don't get detached. You've got to think you've got to remove the right pieces as well. Now as you can see, this is dead easy to trim these pieces off. It's not easy in a lot of drawing packages or vector packages. I've tried doing this in CorelDRAW and it seems like an absolute nightmare. In fact, I've never succeeded. We're going to have the same problem with these letters here. And this E, the middle of the E is going to fall out and the middle of the O is going to fall out as well. So what we're going to have to do is change the design of that slightly. And the way that I'm going to change that design is like this. And then we'll just do a copy of that. There. And then we should do a trim command again. And I'll trim these pieces back like this. Just make sure that we trim it back neatly. And there we go. And now we need to do something with this E. That way. Okay, so that won't fall out now. The middle of the O will fall out and the middle of the A will fall out, and these two pieces will fall out. And the centre of the O will fall out. So we've got quite a lot of work to do on this drawing if we're going to cut these pieces out. That should allow me to do all sorts of things like put a fillet on there of 0. Delete this piece and this piece, and that's all sorted. So that was a bit of a pain, wasn't it, to get all that sorted out. Now why am I not going to do the same thing with this one? Well, that's because I'm going to scan it. So this one we're going to cut and this one we're going to scan. Okay, so let's save this to a file. We're going to output this as a CAD file, DXF format. Got some funny little things going on here as well. Look, yeah, and I know what's causing those. It's another problem that I'm glad we've seen. So we need to go back to here and we need to do the same trimming process on this that we did, because the system has become confused. Trim. So we've got to take all these little links away. So as you can see, that takes quite a lot of preparation work to get this graphics sorted out. Normally I only show you the end result. Right, so what was wrong with these items down here? Nothing, as you can see. So why did they fail? Well, the answer is actually very simple. There is a problem with RDWorks. When you get to very fine detail, like these sharp corners or these funny little pieces down here, RDWorks is not very happy with some of this detail. So what we normally do is we'll choose to scale this up. I'll put this in a box and we will scale this up by a factor of 10. So I'll make it 10 times bigger than it should be. There we go, it's huge. We shall now save it to a DXF file. And now we'll go to RDWorks and we'll delete this version because it's no good to us. we'll import box graphics, and there it is, as you can see. And wow, isn't that big? So what we need to do, go up to the padlock at the top here, and beside it we've got 100%. We'll change that to 10%, and all of a sudden it's back to normal size. Now let's have a look at these letters to see what's happened to these letters now. There we go, all the little curly pieces have gone. RDWorks is unable to deal with some of this detail when you import it as a DXF. And so that's the simple solution. 10 times bigger, and then divide it by 10 when you get back in. Okay, so now we've got to start again. And what we're now going to do is to bring in some additional graphics. Everything we've got on here at the moment is vector graphics. We'll just go and have a look, see if I can find something convenient to import as a bitmap. And there's a convenient something. Now, as you can see, it's pretty blocky, but it's not far off the right sort of size. So what we can do is just check what size that is, and it says it's 65 by 65. Let's take that down to 50. Now, the one thing you will notice is as I brought this in, it's automatically created a bitmap for it. So I can do nothing except scan it, which is fine because that's what I want to do. And then we'll put that one into a group on its own, and we'll put that into a red layer. There we go, that's on a red layer now. So this one is going to be on a black layer. All the perforations, which we'll push our shift key down, and we'll get rid of the outside. We'll get rid of that layer, we'll get rid of that, and we'll get rid of that. And hopefully that should leave just the perforations. And then obviously we've got the outside, so we should finish up with 1, 2, 3, 4, 5 layers here, or 5 items to sort order into. 1, 2, 3, 4, 5. Now, which order should we do them in? Normally, by default, anything that is a scan layer is done first, but in this particular instance I'm going to ask for that cut layer to be done first, and then we'll do this scan, and then we do this scan, then we do the slots, and then we do the outside. Now we can check whether or not our request has been satisfied by coming up here. These white items here are scanned, and the reason why this has to be scanned is because of these dot graphics. You can see how there's no way that the computer can actually scan round the outside or find the middle of these lines. So the only way that it can generate this graphic is if it scans across, stops, starts, stops, starts, stops, and it goes backwards and forwards and backwards and forwards in scanning mode. So because these scans are on different layers, they are done separately. If they're on the same layer, then both of those scans would take place simultaneously in one single scan line. And now it should move on to, oh dear, so it's not done what I asked it to do. I wanted it to do the cuts first, if you remember. You see, that was the first element in the list, but it's got ignored. It hasn't even done that one. So it selected a bitmap in preference to a scan, in preference to a cut. Very interesting. Just make a note of that for yourself. So we'll save this to a U file and nip out to the machine. Okay, well here we are with a change of colour scheme this time. Changing the colour of the card changes the look of the product that you're making. We could make that very slightly darker, but I think it gives quite a nice look to be sort of this pale brown, a bit like a sepia colour. When you're trying to scorch paper, one of the problems that you'll always have is you've got this smoke effect, this smoke halo round here. Now, I haven't found a way of removing that at the moment, except when you're doing wood, you can put some masking tape over it and it will come out beautifully clean, because the smoke will come off with the masking tape. But when you're doing stuff on paper like this, you will get this halo effect. You need to be careful which paper you choose, because as you can see from this red paper that I've used, you get a completely different and much cleaner result. Well, here we have our finished box, and as you can see, the colours that you choose can make a big difference. But the key thing that this demonstration was all about was the fact that if you choose to use Bitmap, the only thing you can do with the Bitmap is engrave it. Whereas if you use vector graphics, you have the choice of being able to cut things, or with the same file, you can select different parameters and you can engrave, or you can mix the two. If you want to do cutting on that Bitmap, you have to convert it into vector files, and that's a completely separate exercise. Well, it is a little gift box. It's not big enough for a handbag. It's certainly not big enough for a pair of shoes for your loved one. Chocolates, possibility. So if you're thinking of a pair of diamond earrings, or maybe even a little diamond ring in a box. Now, whether that gift is for your girlfriend, for your wife, maybe your mistress, I'm sure she'll appreciate it because you personally will have manufactured it. So let's wait till the next session and we'll see what's in store. Thank you very much indeed. Bye bye now.